Lesson 4-1, Example 2. Our objective is learning to use divisibility rules, and here we want to look at using divisibility rules to determine whether a number is prime or composite. And a prime number is a number divisible only by 1 and itself. For example, the number 13. The only numbers that 13 is divisible by is 1 or 13. So we would say the only two numbers that can be multiplied together to get 13 are 1 and 13. A composite number is a number that's divisible by more than two numbers. So we know that 1 and the number itself will be two of those numbers. So let's say look at 12. Well, 1 and 12 will come up with 12. But we can also divide it by 2 because it's an even number. And I know by my divisibility rules that any number that's even is divisible by 2. So 2 would be, it's divisible by 2, it's divisible by 3, it's divisible by 4, it's divisible by 6. And if it's more than just these two, then it's a composite number. So let's take a look at a couple of examples here. Let's determine whether each of these numbers is prime or composite. So the number 23. Well, I'm just going to use my divisibility rules. So I'm going to think, is it divisible by 2? Well, it's an odd number, so no. Is it divisible by 3? Well, let's see. 2 plus 3 is 5. 5 is not divisible by 3, so the whole number is not. Is it divisible by 4? Well, 23 is not divisible by 4, so no. 5. Last digit's a 3. I'm looking for a 0 or a 5. Nope. 6, it needs to be divisible by 2 and 3. It's not. So 6 is a no-go. Is it divisible by 9? Well, if we add up this, if we sum the digits, we get 5, and 5 is not divisible by 9, so no. Is it divisible by 10? Well, you need to have a 0 at the end. It doesn't, so no. It's not divisible by any of these numbers, so it is going to be a prime number. It is only divisible by 1 and 23. Let's take a look at the next number, 48. We're going to do the same thing using our divisibility rules. Is it divisible by 2? Well, it's an even number, so yes. Right there, I could stop if I'm just looking to determine whether it's prime or composite. As soon as it's divisible by something other than 1 or 48, it's composite. Now I could continue going through and determining, are there other numbers it's divisible by, like 3. 4 plus 8 is 12, so yep, divisible by 3. Well, if I know it's by 2 and 3, it's also divisible by 6. 48, yep, it's divisible by 4. 5, no, it's got an 8 at the end, which means it's not divisible by 10 either. 9, 4 plus 8 is 12. 12 is not divisible by 9, so no on there. So it's divisible by all of those numbers, which means it is composite. Let's take a look at number this one, 31. Well, it's an odd number, means it's not divisible by 2. 3, well, 3 plus 1 is 4. 4 is not divisible by 3, so no. That means I also know it's not divisible by 6. 31 is not divisible by 4. If it were 32, yep, but it's not. So not 4. It has a 1 at the end, so that means it's not divisible by 5 or 10. We're looking for 5 or 0, and just 0 here at the end. That leaves me with 9. Well, 3 plus 1 is 4. 4 is not divisible by 9. So, it's a prime number. Finally, let's look at 18. It's an even number, so that means it's divisible by 2. 8 plus 1 is 9. 9 is divisible by 3. So it's divisible by 3, which means it's divisible by 6. 2 and 3, that means it's 6. By 4, well, 18 is not divisible by 4, so that'll be a no there. The last digit's an 8. That means it is not divisible by 5 or 10. So finally 9. Well, 8 plus 1 is equal to 9, and 9 is divisible by 9, so it's a yes for the 9. It means it's a composite number. It's divisible by 2, 3, 6, and 9.